Dear students, today we are going to study about properties of gas. First, let's study what is a matter. Matter we can divide into three categories. One is solid, liquid, gases, as we know. Solid has a permanent attraction between particles and rigid particles locked into one place. Therefore, it has a fixed volume and shape that particles in solid state cannot move or slide past one another. Liquid has temporary attraction between particles and these particles can move or slide past one another. Therefore, shape of the liquid is changed according to the container which it occupies, and it has a little free space between particles. And gas, we can say it has no attraction, or it has a negligible attraction between particles. Therefore, that particle can move past one another, and lot of free spaces between particles has in this gas state. These images are shown their behavior between particles of solids, liquids and gases. Now let's go to about gas. Study matter can be divided or classified into three categories according to the attraction between particles. So then gas are considered as a negligible attraction between particles. Therefore, for an ideal gas, we should have some definition for that gas. What is the gas? So let's study their ideal. If there's an ideal gas, so what are the features they should have? There are several assumptions can be considered for an ideal gas. One is consists of a large number of tiny particles that are far apart relative in their size, and collisions between gas particles and between particles and container walls are elastic collisions. These elastic collisions, one in which there is no net loss of total kinetic energy, and gas particles are in continuous, rapid and random motion. There are no forces of attraction between particles. As we discussed, there are negligible forces in gases, but for an ideal gas, there may be perfect gas, there should have no forces of attraction between particles. And next one, the volume of the gas particles is negligible compared to the volume occupied by that gas. That means the volume of the container is very high with compared to the total volume of that gas particles. There are several properties we have to consider for gases. The first one is pressure and volume and amount. We can calculate the amount using moles or number of molecules. And next one is temperature. Let's consider this individual part briefly. Let's first consider the pressure. The pressure is defined as the force the gas exerts on a given area of the container in which it is contained. For example, let's take when you have filled up a tire, you know that there are pressure applied for the tire, the wall of the tire, we measure that value in psi. We can measure the pressure using different units. At sea level, the pressure of atmosphere is 1. We call this as a 1 atmospheric pressure. The unit we write down as ATM, simple ATM, for the 1 atmospheric pressure at the sea level exists in the normal condition. So therefore 1 atmospheric pressure is equal to 1.013 into 10 to the power 5 pascals. Pascal is the SI units. We are measuring the pressure of gas. The 1 pascal is equal to 1 Newton per square meter. That means the force of 1 Newton applied for 1 square meter is called 1 pascal. That is the SI units we are measure pressure. There are several other units in classical way we call mercury millimeters. It is around 760 millimeter Hg at the sea level. Therefore, you can have an idea about the units of 1 atmospheric pressure equal to 760 mercury millimeter values. The mercury millimeter also used to measure the pressure. And next is torr and psi are the other classical units measure the pressure of gases. Therefore, please attend those units and you have an idea, you have an knowledge to convert those units into other units. Therefore, please study these units of pressure for your future works. Next important property of gas is volume. Volume is the three-dimensional space inside the container holding the gas. The volume also can measure using different kind of units. The SI units for volume is the cubic meter. Moreover, we can use liter, milliliter, or there are several units to measure. You can take an idea about the liter size. You can take some mega bottles or soda bottles. There are 1 liter bottles. So if we remove all the liquids inside that one and when you close that bottle, inside the bottle there are gases contained 1 liter. So you can take an idea about the size of the volume. Next one is the amount. When you measure the amount of any material, you can count using integer values 1, 2, 3, 4. Like you can count the amount of any property. But here the gas contains in some small particles. Therefore, we can't measure very tiny particles in normal methods. The amount of substance is strictly, as we already learned, the SI unit for amount of substance is the mole. Therefore, we are measure this amount of gases using amount of moles. 1 mole contain around 6.022 into the 10 to the power 23 number of molecules. 1 mole contains 6.022 into the power 10 into the power 23 number of particles or molecules in 1 mole of amount. Therefore, we can easily to count the number of gas moles. Therefore, the amount we are measure using moles. I think you have a good idea about moles. Therefore, we can take this moles, number of moles, to measure the gases. Next important feature of gas is temperature. Temperature is the measurement of heat or how fast the particles are moving. Gases at room temperature have a lower boiling point than things that are liquid or solid at the same temperature. we can take an idea about temperature using this data. Water will be evaporate at 100 degree of Celsius. That means their boiling point is 100 degree of Celsius. Therefore, water exists as a gas above 100 degree of Celsius. And in alcohol, that value is 78. Therefore, above 78 degree of Celsius, alcohol can be exist as a pure gas. However, oxygen has a boiling point very low. It's around minus 183 Celsius. That means in the room temperature, think about it's a 25 degree of Celsius, oxygen exists as gases. However, at 25 degree of Celsius, water or alcohol cannot be exist as gas, it is exist as a liquid. Therefore, the temperature define their physical state as well. It is always use absolute temperature. We are measuring using Kelvin when working with gas in everywhere in science. These are the scales to convert Fahrenheit, Celsius and Kelvin. Please use this Kelvin value when you are going to calculate or do any works about temperature when you are working with gases or anywhere in science. Therefore, the scale of Kelvin is very important for temperature. Normally, we are measure the temperature using Celsius or Fahrenheit. However, in scientifically any calculations and any mathematical expressions, we have to use that Kelvin scale. There are standard conditions when we are working with gases. The standard conditions for temperature is and pressure set of conditions for experimental measurement to be established to allow comparisons to be made between different set of data. For example, we have to use 0 degree of Celsius when you are working in gases. It is also same to 273 Kelvin. And the pressure we want to use for standard value for gases are 1 atm, that is 1 atmospheric pressure. It is equal to 101.325 kilopascal. That is the standard condition values. Therefore, when we are dealing with any gases for any experiment, we have to keep these standard condition for comparisons. Next, very important part, how do they all relate? That means we now learn about several features and several properties of gases, that some relationship of gases may be easy to predict, but some are more complex. Now that we should understand the factors that affect the behavior of gases, we will study how those factors are correlated. The first law of the gas is Boyle's law. We should learn. This law is named for Charles Boyle, who studied the relationship between pressure and the volume of gas. It's around mid-16th century, and Boyle determined that for the same amount of a gas at constant temperature result in an inverse relationship. When one goes up, the other comes down. That means in a particular amount of gases, if you increase the pressure at same temperature, the volume of the gas should be decreased. That is, he got idea from his experiments. Therefore, this Boyle's law describes the relationship between pressure and the volume of gas. This gas volume and the pressure is inversely proportional to each other at constant temperature and the amount of gas. Therefore, this again I will introduce this at a constant temperature. and constant number of gas molecules exist at P1 and P1 pressure and V1 volume. If you change the pressure into P2, the volume also will change into V2. Therefore, this pressure and the volume has a relationship to equal to this equation. Therefore, you can calculate any pressure and volume value at constant temperature and the unit or constant amount of gas. The pressure and the volume has this kind of relationship. Next law of the gas is Charles' law. This law is named for Jacques Charles, who studied the relationship between volume and temperature around the turn of 19th century, and this defined a direct relationship with the same amount of gas. He found that as the volume increases, the temperature also increases. If the temperature decreases, then the volume also decrease. Therefore, temperature and the volume has the direct uh, relationship. That means if one increase, other one also going to increase. Now let's see what are the relationship between this temperature and volume. Let's make a expression for. Now we know that the Charles describe the relationship between volume and the temperature of gases. Therefore, we can take this kind of expression V1 T1, that means the volume and the temperature at one condition can be changed. When you change the temperature to T2, the volume will decrease to V2. Or if you change the volume to V2, definitely the temperature will schedule into T2. That is all conditions at a constant pressure and constant amount of gas. Therefore, the relationship between volume and temperature has a direct relationship. When one increase, other one also increased to equal this equation. Next important law of gas is Gay-Lussac law. For a gas at constant mass and volume, the pressure and the temperature are directly related. That means when you increase the pressure, definitely temperature will increase. Or if you increase the temperature, the pressure will increase in a considered gas amount. Therefore, the Gay-Lussac deals with the temperature and the pressure. And we know gas are directly related at constant mass and volume to the pressure, and when you use the temperature measurement using Kelvin at constant volume amount and the amount of gas is constant, the pressure and the temperature has correlation in shown in this equation. That means T1 pressure at T1 temperature has considered in a 1 unit of gases. If you change the temperature into T2, pressure will change into P2. That is the idea we can take using Gay-Lussac law. Using this, every gas laws of these three, Boyle's law, Charles' law and the Gay-Lussac law, scientists should formulate new gas law. It called combined gas law. This gas law is P1 V1 divided by T1 is equal to P2 V2 or T2. That means two conditions. P1 is the condition at one stage and 2 is the condition at second stage. Therefore, we can derive next different equations for the relationship between pressure, volume and the temperature. Therefore, if you change one property of gas, others will arrange into this according to this equation. This is also considered for the unit or constant amount of gases. Next important principle is Avogadro's principle. For a gas at constant temperature and pressure, the volume is directly proportional to the number of moles of gas. That means if you increase the amount of gases, definitely the volume will increase if it is in a constant temperature and pressure. Therefore, Avogadro's principles deals with the volume and the number of moles of gas at constant temperature and pressure, and it is true only for ideal gases. Therefore, Avogadro's principle can be considered using this equation at constant temperature and pressure, V1 and N1 at one condition. If you change the number of moles to N2, the volume of gas will be changed into V2 as shown in this equation. Next important feature or important law we should know is Dalton's law of partial pressure. The total pressure of gas, if you consider there are several number of gases in one container exist, think about A gas, B gas, C gas or that kind of things. For example, oxygen, nitrogen, there are several gas exist in a single container. The pressure developed by single gas we call partial pressure. That means the PA means pressure developed by gas A. PB means pressure developed by gas B. If you have oxygen and nitrogen, we can use PO2 or PN2 for this example. So therefore, this total pressure of total gas is equal to the summation of partial pressures of other gases. Therefore, let's consider the partial pressure. This partial pressure is also equal to total pressure into the molar fraction XA. What is this XA? Means number of moles in A gas and number of moles in all gases in total, and in A divided by in total is equal to XA. That means let's think about oxygen. X for oxygen is equal to number of oxygen gas molecules in this container divided by total number of gases in that container, that we call molar fractions. Therefore, partial pressure is equal to total pressure multiplied by the molar fraction. This is also very important law when you are dealing with gases. Scientists could able to derive a single gas law we call ideal gas law using laws we learned earlier into one gas law. This is we call ideal gas law. It is PV is equal nRT. This P is for pressure, V is for volume, and N is for amount of gas in mole, and T is temperature in Kelvin. So therefore, this R is a constant. We call this is a universal gas constant. This R we can take using a value is 0.08206 cubic decimeter atm per mole per Kelvin. Here you can use this value when you measure the pressure using atmospheric pressure and the volume using cubic decimeter. Or we can use this R value as 8.315 cubic meter Pascal per mole per Kelvin, or we can say cubic decimeter kilopascal per mole per Kelvin. If you measure the volume using cubic meters and pressure using Pascal, you have to use this R value. So therefore, this is very important equation. Therefore, you have to do several calculations. In different state, you have to calculate pressure, volume, number of gases in mole and temperature using this equation. Therefore, please do your assessment, and there are several practice questions in your VLE to understand these gas laws. Please do that exercises for learn more. And this is the end of the lesson, and thank you very much for listening. Please attend to the assessments and questions to learn yourself about these gas laws. Please take this lesson as the guideline for your learning. Thank you very much for listening.